Our next session will start within 2 or 3 minutes. Our next session is regarding a flexible power solution for data center. Actually, it's from Starline. Starline is a US-based company. So Starline has done a lot of projects in Bangladesh. Actually, I am a fan of Starline due to, as a data center guy, as you know that, the power should be very flexible in data center. So I think you will learn a lot of things from this session. And if you have any question, you can write in the question and answer box. Okay, let's enjoy the session.
Thanks for the introduction. Hello everyone, and I hope all of you are doing fine at these times. I thank you all for joining me for this brief talk about reliable power distribution in the data center. So the topic for today's talk would be reliable power distribution in the data center. I would also like to thank the DCsUMMIT team for giving us an opportunity to be part of this virtual event. I'll be talking about reliable power distribution within data center, which is the topic for the day. And why is this important? Unexpected breakdown is a big concern, and customers have reported loss of huge dollars in revenue per second due to unexpected breakdown. When a rack or server goes down, and there are different methods that can help identify these issues in advance before they become critical, thus giving the data center owner the ability to schedule downtime to address the issue before it becomes critical. Today, what we do is we'll be discussing some tools that Starline offers to increase the reliability within the data center, and also how that helps to improve the total cost of ownership. When choosing a busway system, you want it to be as reliable as possible because these are used in mission critical space, and we don't want any kind of a downtime because any downtime is a huge revenue loss. So we need to ensure ways to avoid any unexpected breakdown by improving the reliability. Before I go into the reliability aspect, I would like to quickly touch upon the continuous access busbar architecture, just to familiarize the important elements, especially for those who may not be aware of or may not be familiar with the continuous access busbar. The entry of the busway is the first point to which the incoming cable from the low voltage panel or the UPS gets connected, and then this entry is connected to the sections of the busway and use a joint kit to do that. And the busbar runs along the aisle. The bottom of the busbar is continuously open, so you can tap off power wherever you want using the plug-in unit or the tap-off unit. And then you can connect that to the rack PTU. So that's typically the architecture. So there are options to enhance the reliability. Let's look at some of those options and how Starline can help in achieving those. There are three options, the three places where failures can occur within busway system in the above architecture. The first one is the entry unit. This is where the cables from the low voltage or UPS panel comes and gets connected. The second is the point where two busways get connected using a joint kit. The third, the plug-in units, also known as tap-off points. We look at these three areas to see how we can improve reliability. The weakest point in many electrical systems is the joints, or where connectors make physical connection. The simplest way around this is to reduce the number of joints. And how do you do this? That is by making the runs of the busway as long as possible. The within Starline, we can offer up to 20 meters on a 6-meter section. For some ratings, or most of the ratings actually, which reduces the joints and hence reduces the failure points. Another way to improve the reliability is by having a joint which itself is reliable. And in Starline, we do this by a unique press-fit connection. Here we eliminate bolts, and hence sparking of those bolts are not required. We achieve this by means of a unique U-shaped conductor, and this allows for a knife blade type of compression frame at the joint. This makes the joint 100% reliable and maintenance-free. Less reliable type of joints that use lock bolts, the joint back, which presses the bar together to ensure connection integrity, which over time can become loose and result in a very poor connector connection. But this feature is unique to Starline as it makes the system maintenance-free at the joints. Otherwise, the joints have to be locked periodically, and this calls for shutdown of the bus bar. And every shutdown is a revenue loss for the running data center. Power monitoring of busway system is another way that a data center operator can increase the reliability of the facility. It allows monitoring of entire busway run as well as an individual circuit. By doing this, it can alert the data center manager of an issue, so that the data center manager or the person who's managing the data center can take a proactive or preventive action. The Starline solution uses a power monitor, which is a revenue claim monitor, which makes the metering option a very reliable and accurate one. And also, in case of Starline solution, the monitoring can monitor multiple circuits, and they can integrate with DCIM or BMS. And communication to the BMS or DCIM can happen via wired Ethernet or can happen via serial communication, such as Modbus RS485 kind of a protocol. Also, the option is to use a wireless, which can be a third-party proprietary protocol, or can use an open protocol such as a Wi-Fi protocol. Also, there is an option to use Modbus and SMFP protocols simultaneously, which is quite an advantageous option. It also has an embedded web page for easy access of data. The power monitoring solution can work in conjunction with other tools to assist in proactive or preventive maintenance, and helps in improving the reliability, and in turn improves the business continuity and the total cost of ownership. As we go through the slides, I will let you know how the monitoring system works in conjunction with our thermal monitoring NV units, and how it assists in doing preventive or proactive maintenance. Apart from improving reliability, the metering solution is also critical to improve the PUE. Cost of power remains the single largest operating expense for any data center, because power is quite an expensive contributor within the overall data center budget. Power usage effectiveness, or PUE, using source energy consumption is a preferred energy efficiency metric for data center. This PUE measurement happens by getting the readings from the source which is consuming it, and hence monitoring power is important to even manage power. The largest and the most critical electrical connection while using a busway system is a connection made at the end feed, where the feeder cable comes and makes a connection to the busway system. Like I showed in the previous slides, where I showed the architecture where the output of the low voltage panel or the output of the UPS would use a cable and get connected to the end feed. So easiest way to monitor the integrity of these connections to read and log the temperature at the lux. So what you do is the values and the trending of the temperature data as current to identify issue. before it happens and then schedule a preventive maintenance. One method to do this is via use of a critical power monitor, which can provide real-time temperature data. This data can be logged, and when a large data seep in the temperature, then an investigation can be performed. There are 4 temperature nodes that are provided at each of the lugs, and then there is one temperature node that's provided for the enclosure. So these temperature nodes monitor the temperature, and then they give this information back to the feed meter, which in turn communicates the data back to the BMS or the DC line. And you can use that information to take a proactive or a preventive action. Temperature data is actually charted along with the CPM power data for advanced maintenance option at the DCIM or the BMS level. If the temperature levels are above desired values, then a proactive maintenance can be done. Next, we see how to connect the temperature sensors or the temperature nodes. Firstly, the temperature node bracket is installed on the lugs on the infeed. To this bracket, the temperature node is attached. There are actually different types of brackets that are available, such as type J, type F, type G, and type H. And these brackets are dependent on the type of lugs that are there in the infeed unit. There are 4 data points. In total, there are 5 data points, 4 data points for each of the lugs and 1 data point for the enclosure. These data points are attached to the lugs using a bracket via a temperature node as discussed in the previous slide, and 1 data point for the enclosure. The data point or the temperature node, they keep updating every 1 second. And in 30 seconds, if there is no update or feedback from the data node or the data point, then an unresponsive alarm is triggered. Then the data center manager can intervene and see what is wrong. There's something wrong with the monitoring system. Temperatures can also be preset. In the factory, set temperatures for the nodes are 85-degree Celsius, and for the enclosure, it is 75-degree Celsius. Our user also have an option to set their own temperatures, one for the node and one for the enclosure. Another method to determine blood temperatures at the infeed is via the use of IR windows. Though IR windows are more labor intensive than the use of critical power monitoring, because the operator will require to physically take pictures at the infeed, then these pictures have to be compared to pictures which were taken initially, and then check if there is a large delta in temperatures. If there is a huge variation in temperature, then a further maintenance might be required. So this maintenance can be performed without any downtime or without a need for a significant personal protection. The manner in which the plug-in unit or tap-off makes a connection to the bus is extremely important to data center reliability. Some products use conductive leads to ensure good electrical connections or make the connections via point contact with bus bars. But both of these designs can be unreliable and could lead to issues in the future. Robust designs with fewer moving parts are inherently more reliable, such as simple insertion requests to make electrical connections. Many of the plug-in designs in the industry use moving parts such as lever to engage the plug-in unit with the bus bar. And these designs can be unreliable because accidentally if the lever gets operated, then the tap-off unit can get disengaged from the bus bar. And this can lead to shorting and could be a safety hazard. So Starline design has no moving part required to engage the plug-in unit, and hence a better reliable option, and also ensures a industry-leading mean time between failures. Also, the twist and turn feature of the Starline plug-in unit removes any oxidation from the contacts. Because of this, the conductivity is always very good. Also, the plug-in unit, the potential mechanical connections that can fail are the connection to the OCPD of the line at the roadside. This can be handled by an IR window on the plug-in unit on the face of the plug-in unit. These windows allow for IR scanning without the need to power down the circuit, and is safe to do under load. The picture you see on the right side is an example of the data the user would record. This ensures business continuity is maintained without facing unexpected breakdown due to overheating at the OCPD connections. So the next important point which we need to cover as part or to ensure reliable power distribution in data centers is to see how we manage residual currents. Server racks have a tendency to leak small amount of AC or DC fault currents to earth by design. That's the nature of the server racks. If we have to use RCDs, that can be problematic because the RCDs will trip often, and that can be a nuisance. So instead, what we could do is we could introduce a residual current monitoring, which can be part of the monitoring features. And this can detect deteriorations of the insulation level at an early stage and communicate this back so a preventive or a proactive action can be taken. Residual current monitoring. How does it work and how Starline can address this with the solutions they have? It monitors the level of residual earth current and preset threshold alarms reporting back to client's headed system, with which a preventive investigation can be done to prevent potential fault. So the advantage you have is the fault can be detected before they could occur, so that you could avoid any unexpected downtime. You don't need for any fixed wire testing. This reduces the operative costs and reduces risk to power redundancy. And as part of the Starline metering solution, we provide the residual current monitoring. So this is an important tool that can be useful in ensuring reliable power distribution with the data center. So far, we spoke about reliable power distribution in the data center, the different tools to ensure reliable power distribution, and how Starline solution we can ensure reliable power distribution. Before I conclude, I would like to let you all know a little bit about Starline, especially for the benefit of those who might not be aware of Starline so much. Starline, we are a pioneer in data center bus bars, and the introduction of the track busway or the continuous access bus bar was done by Starline more than 35 years ago. Starline has more than 85 years of history as an electrical contractor and subsequently an electrical manufacturer. And now Starline is part of the Legrand group. Starline is headquartered in Canonsburg, which is a place very close to Pittsburgh, and has offices across the globe with a very strong partner community across the globe. We have 3 factories, one in the US, one in the UK, and another one in Singapore, where we manufacture our bus bars. The total manufacturing facility is about 170,000 square feet. So as Starline, the markets we serve are data centers, industrial, retail, commercial and office spaces, and laboratories. So let us see what we can do in each of the markets. Firstly, data centers. For the data centers, which is the sweet spot for the Starline solution, we can offer white space, unique plug-and-play continuous access track busway, where you can tap off power without shutting down the busway. This ensures any moves, adds, and changes can be done without any downtime. Ensures high scalability by way of adding circuits to power new racks in a live environment. Ensures a high availability by minimizing the downtime, and a high reliability by way of the designs and solution offering which we spoke in the earlier slides. So the next segment is the industrial segment. Within the industrial segment, we have a huge demand of our busways, especially in the automobile segments, where our plug-and-play feature with high safety is demanded by customers. So industrial segment where we cater includes automobile segment, the garments, and industrial shop floors, etc. So the picture what you're seeing is some of the photos which we have taken from some of our existing customer in the automobile segment, where you can see the bus bars are run along the assembly line and where we're tapping off power to power the various junctions on the assembly line which needs power. And the plug-and-play feature of Starline helps us to remove the tap-off and connect it to wherever you need. So this is a big advantage, especially in the assembly space within the automobile sector. So the next segment we cater is the retail segment. We see a lot of demand in the dynamic environment in the retail space. So the retail stores keep changing their design and the cash counters keep moving. The Starline solution fits very well into this modular space where plug-in units can be removed and fixed where the demand is. Some of the large retail customers across the globe demand a Starline solution. Also, the ability to integrate the lighting fixture in the same busway makes it convenient to manage the lighting and the power load in the same bus bar. So as you can see in the picture, we've used the same bus bar to connect the lighting as well as the power loads. So both are serviced by the same bus bar. Yeah, we also cater to commercial and office spaces. So for commercial and office spaces, we have a raceway product, which is called a plug-in raceway. This is more of a sturdy bus bar, and this can be mounted on the surface, and different sockets can be fixed based on whatever is required. This solution is ideal for commercial spaces and for office area. As you can see from the picture here, the plug-in raceway is mounted on the surface of the wall, and sockets have been fixed at locations wherever you need power. So the next segment which we cater to is the laboratory. Starline solution has been in good demand within the laboratory environment, where move and changes happen very often. University labs, hospital labs, and engineering testing labs are some examples where Starline solution is prevalent. This concludes our presentation. Thank you for your time. If anyone wants to know more about Starline, you can reach me on my email ID or you can give me a call on my handset number. Thank you.
Thank you very much. Now there is a lot of questions. Okay, let's go to the question and answer session. Sathya, can you give the one?
Yeah, yep.
Turn on your video or not?
Yeah, I think looks like I have a little bit of a problem. As I told, I'm a little away, so apologies. Couldn't be present in person. So video looks to be. I've been trying to switch on the video. Seems like there is some problem. So
okay, no problem.
So maybe we might have to just stay with the audio.
Okay. So you have a lot of questions actually. I will go one by one. Okay.
Okay.
First one is regarding busbar. In terms of other load protection, how your busbar protect the load, and during any maintenance period, how your busbar isolate the load without using any external isolator.
Typically, our plug-in units or the tap-off box, they come with a breaker on it, which is required for you to, which is used to protect the load. This is when your bus bar is running. If you're doing any kind of maintenance, so maintenance generally happens on a shutdown. So as such, as you would have seen in my presentation, the Starline solution doesn't call for a maintenance, but if the customer wishes to do a maintenance, he will have to do it on a shutdown. But during the running, the load is protected using a breaker on the tap-off box or on a plug-in unit. So any fault, the breaker would trip. and take care of the load.
Okay, and another question.
Have I answered?
Yes, thank you. And another question is, what is the unique about Starline and how it is different from other busbar in the market?
Firstly, in terms of uniqueness, I would say it comes to the industry experience. I would say Starline has been in the electrical industry for 90 years and has been in the power distribution space itself for more than 35 years. And if you look at Starline, the track busway, that's been, I would say Starline pioneered that. And it's the first of its kind meant for the data center space. There are bus bars in the industry, which you typically see, which is used to run between a panel to a low voltage or a high voltage switchboard, or you run the bus bar between floor to floor. But the first bus bar that was meant for a data center was introduced by Starline, and it was called the track busway. And obviously, because of these reasons, Starline has the largest customer base across data centers who use busbar for power distribution. Finally, most of the points discussed today in my presentation are very much unique to Starline, which makes the difference between Starline and the other bus bars in the industry.
Thank you. Another question is, do you have any DC voltage BBT and plug-in unit?
Yes, we have DC 380 volts, and we do have DC 250 volts, and we also have installation with DC 48 volts. And the bus bars are very similar. It's same as our AC bus bar, just that we would have a DC protection at the socket level. At the tap-off level, it will be a DC protection as against an AC protection. So that will be the only difference. Otherwise, the bus bar, what we would be using would be very similar to what we cater to the AC requirements.
Okay, thank you. And another one is, what are the major point of failures in power distribution in the data center?
Like I mentioned in the presentation, I think the point of failures typically are the points where you connect a cable to a bus bar, or when two bus bars get connected. So within the power distribution architecture, the first point of failure and the major point of failure is when you connect the two pieces. The joints is the most critical aspect. And that is where Starline has the biggest benefit because most of the industry bus bars, they use bolts, and these bolts have to be torqued very frequently, because what happens over time, because of the bolting nature, the connection loosen up. And once they loosen up, there is a good chance that they could generate a fault, and that would lead to a breakdown, and you cannot afford a breakdown in mission critical space. So the foremost thing is the joining of two bus bars. Secondly is the connection where you get the low voltage cables connecting into the end feed, which I showed in the presentation, or the output of the UPS. This connection is typically using a cable. So since this again is a connection, this is another point of failure. So that is why within Starline, we have come out with a solution which ensures that you could take a proactive or a preventive action before it goes down. And thirdly, again, the plug-in units. The plug-in units again have connection on the load side and on the line side. So these connections can create a failure. So again, we have come out with this unique IR window. I'm not sure if there's anyone who provides that currently, but we have this IR window, which we provide on our tap-off box. So this helps customer to do a proactive or a preventive maintenance to ensure there is no unexpected downtimes. So these three are the three critical points which we would see as a point of failure within the power distribution for data centers.
Okay, another question is the plugin unit has any monitoring features? If has, then what are the protocols? And also, the plugin unit have any remotely on-off features?
Yep, we do have, Starline has multiple monitoring features, and we have different protocols which we support. We support the Ethernet, your Modbus, your serial communication, which is your RS-485. We also have Wi-Fi. Wi-Fi can be either your open protocol, which is your open protocol Wi-Fi, or you could use a third-party wireless, a third-party proprietary protocol can be used to communicate between the DCIM metering box and the DCIM or the BMS. And there's another question, Masood. Can you repeat that? There was another question that was included.
Starline
Apart
has
from metering?
end-to-end busway solution without using any connection cable in the short length or cross section from the LT panel.
Can you repeat that, Masood?
Starline has end-to-end busway solution without using any connection cable in the short length or cross section from the LT panel. That means from LT panel to please.
Yep. If at the moment when we are talking, as such, now as since we're part of the Legrand group, if you're going to ask me, the answer is yes. We do have a solution which would join into it. We could come from the outside of the plant, which with an IP68 kind of a bus bar into the gray space and then into the white space.